In this video, we'll study digital signal processors based on Harvard architecture. In one of my video, we have already studied Von-Neumann architecture. It is little different from Von-Neumann architecture known as Harvard architecture. It consists of address generator, program control unit, input-output devices, arithmetic logic unit, program memory, data memory. Along with this, it has program memory address bus, data memory address bus, as well program memory data bus, data memory data bus. Along with that, it has two more special units known as multiplier and accumulator, in short known as MAC, that is MAC, and another unit is shift unit. As we seen in Von-Neumann architecture, the memory for program as well as data was same, but in case of Harvard architecture, the memory for the program and the memory for the data are different, as shown here. The address generator, the function of the address generator is to generate the address of the memory location from which the data is to be accessed. Here, program memory address bus holds the address of the program memory and data memory address bus holds the address of the data memory. As here we can see that the program memory address bus is pointing to program memory and data memory address bus is pointing to data memory. The address is generated by the address generator. And here data bus is used to transfer the data between memory and processor. Here we have program memory data bus. Program memory data bus holds the data from the program memory and data memory data bus holds the data from the data memory. The program control unit will fetch the instruction from the memory and it will decode it and it will execute. After executing, the data is stored back into the memory. The function of arithmetic and logic unit is it performs arithmetical operations as well as logical operations. It retrieves the data from the memory, performs the operation and stores back the result into the memory. Sometimes it is necessary to read the data from the input devices and necessary to display the data onto the output devices. Also here we can see that the multiplier and accumulator block is a dedicated hardware used for digital filtering operations. Similarly, we have another unit known as shift unit. The function of this is it is used for scaling operation for fixed point implementation when the processor performs digital filtering operations. Harvard processor fetch the program instruction and data in parallel at the same time. That is, if we consider this as a clock cycle, in first cycle, this is the first cycle, it will fetch the instruction, and in second cycle, that is from here to here is the second cycle. In second cycle, it will execute the instruction. As well as while executing the previous instruction, the Harvard processor will fetch the next instruction. That is, fetching of the next instruction and executing of the previous instruction will take place parallelly. That is, in this cycle it will fetch next instruction. Similarly, in this cycle it will execute the second instruction. So this process will be continued. So here we can see that the execute and the fetch cycle are overlapped. Here execute and fetch cycles are overlapped. So this process is also known as pipelining operation. Thus, by comparing Harvard architecture with Von-Neumann architecture, the Harvard architecture speed is more because it execute and fetch the instructions parallelly. Thank you for watching.